Kia ora, and welcome to a lesson on the modulus function for Cambridge P2 and P3 mathematics. So the modulus function looks like this. It's two straight lines going down with something in between them. Okay? Modulus x is defined as giving the solution of x when x value is greater than or equal to 0, and it gives the value minus x if the x value is less than 0. This looks kind of complicated, however all it's saying is whatever value is between the two brackets, the two modulus lines, gives a positive value. Okay? For instance, if I have modulus minus 3, the solution of modulus minus 3 is positive 3. Or if I have modulus 4, the solution of modulus 4 is still 4, because 4 is greater than or equal to 0, so it just gives me 4, and because minus 3 is less than 0, so I take the negative of what that is, which is the positive value 3. So that's the modulus function in its basic components. However, we're going to use the modulus function in solving questions. So let's have a look at our first question. Modulus 2x minus 1 is equal to 3. So, as I said, the modulus function says whatever's inside our modulus, whether it be positive or negative, will produce a positive answer. So, when I think about what is between these two brackets, and I think about what 2x minus 1 would be, either 2x minus 1 is the solution positive 3, or 2x minus 1 could be the negative solution 3. Because if minus 3 is 2x minus 1, it still gives me the positive 3 answer. So when I want to find out what x is, I need to consider both situations. So I'm going to solve these two now. So if 2x minus 1 equals 3, 2x equals 4, and x equals 2. And if 2x minus 1 is minus 3, then 2x is minus 2, and x is minus 1. Once I get my two solutions, I just need to do a quick check to see whether both solutions actually satisfy the original question. So let's try x equals 2 in here. So 2 lots of 2 minus 1, is that equivalent to 3? So 2 times 2 is 4 minus 1, which is mod 3, and mod 3 is 3. Okay. Let's try x is minus 1 in here, so 2 lots of minus 1 minus 1. Is that equal to 3? Well, 2 lots of minus 1 is minus 2. Minus 2 minus 1 is minus 3, which is 3, because mod minus 3 gives me the positive solution, 3. Let's have a look at another example. So both of these are accepted, so both of my solutions are usable. Let's have a look at another one. So, example 2, modulus x minus 4 is equal to 2x plus 1. Okay, so again, I need to consider both situations being positive, give me a positive solution and a negative solution. So either x minus 4 gives me the positive solution, 2x plus 1, or x minus 4 could give me the negative solution of 2x plus 1. Okay, and it's all of that will be negative. So again, let's solve both of these equations now. So minus 4 is equal to x plus 1. So x is equal to minus 5. Over here, x minus 4 is equal to minus 2x minus 1, which is 3x minus 4 is equal to minus 1, which is 3x is equal to 3, which is x is equal to 1. Now let's test both of these in the original equation. So, modulus minus 5 minus 4, is that equal to 2 lots of minus 5 plus 1? Well, minus 5 minus 4 is mod minus 9, which would be a positive 9. 2 lots of minus 5 plus 1 is minus 9. Well, mod minus 9 is not equal to minus 9 because mod minus 9 would give me a positive value of 9, so this is not true. So this solution does not work. Okay. What about the answer of 1? Well, let's try 1 in here. So modulus 1 minus 4 modulus is equal to 2 lots of 1 plus 1. Well, 1 minus 4 is modulus minus 3. And 2 lots of 1 plus 1 is 3. Is modulus minus 3 equal to 3? Yes, it is. So my only solution is x equals 1. I ignore x equals minus 5. Let's have a look at another example. So example 3, I've got modulus 3x plus 4 is equal to modulus x plus 5. So this is a bit different to previous ones because now I've got moduluses on both sides of my equal sign. Okay, so I need to get rid of the moduluses. There's two ways of doing that. Either I can think of 3x plus 4 and x plus 5 as giving me positive and negative solutions either way, which gives me the possible answers of 3x plus 4 is equal to x plus 5, or 3x plus 4 is equal to negative x plus 5. Okay, I don't have 4 solutions by doing positives and negatives on both sides. I've only got 2 because well, either both are going to be positive values, which gives me both positive, or both are going to be negatives of each other, which would still give me positives because the negatives would cancel, or one of these two is going to be negative and the other one is going to be positive, which is symbolized by this one, because if I have negative of this side, it's this equivalent to if I just had the negative of this side to the positive of that side. So there's only really 2 ways of looking at this. Okay, and that's a fairly basic thing to solve. However, there's a second thing I can think about. I'm going to look at it this way just for the purposes of understanding some other parts of modulus later, is that if I have modulus a, I can say that modulus a squared is equal to a squared. Okay, this is true because when you square any value a, you only ever get the positive solution anyway. Okay, so mod a squared doesn't really do anything else other than it changes the value inside the modulus to a positive first and then square it, rather than squaring the negative value and getting the same solution anyway. So one way to get rid of moduluses is by squaring both sides here. So I can say that 3x plus 4 squared is equal to x plus 5 squared. Okay, I can then expand my brackets. 9x squared plus 24x plus 16 is equal to x squared plus 10x plus 25. Make it equal to 0 and then solve. So then 8x squared plus 14x minus 9 is equal to 0. So I can solve this either via factorization or via the quadratic formula. I'm going to use a quadratic formula just because it's quite a large quadratic, so I don't want to be having to think too hard about what numbers I could use. So minus 14 plus or minus 14 squared minus 4 lots of 8 lots of 9 all over 2 lots of 8. That is what x equals. So x gives me the solution of either a half or x is equal to minus 9 over 4. Okay, and if I try both of these x values in my original equation, they do both give me the solution. So both of these do work. Okay, let's have a look at another example. So example 4, I've got x plus 3 in modulus plus modulus x plus 5 is equal to 10. So to get rid of the modulus brackets, I need to have one of those on itself on either side of the equation. So my first step here is going to be to say mod x plus 3 is equal to 10 minus mod x plus 5. Okay. Now that I've got the modulus on the left hand side by itself, I can get rid of the brackets by taking positive and negative. I cannot do what I did a second ago by squaring, because if I square the right hand side, all I'm going to end up with is 100 minus 20 mod x plus 5 plus x plus 5 squared, and it doesn't get rid of a modulus if I do that. So I'm going to have to use the other method that I mentioned a second ago, which is taking the idea that x plus 3 will give me two solutions. Either x plus 3 is equal to the positive variant of the right hand side, 10 minus mod x plus 5, or x plus 3 is equal to the negative variant, which is mod x plus 5 minus 10. Okay? I've still got modulus, so I still need to get rid of that. So now I need to take the 10 off the right hand side and make it so that the modulus is by itself on the right hand side. So x minus 7 is equal to minus mod x plus 5. Still a minus there, so I need to get rid of that. So 7 minus x is mod x plus 5. And then the other one becomes x plus 13 equals x plus 5, mod x plus 5. Okay, now I've got the moduluses by themselves. I need to take the two different solutions that I can get from the mod x plus 5 being the positive and negative variant of the left hand side. So either 7 minus x is equal to x plus 5, or x minus 7 is equal to x plus 5. Okay, let's have a look at this one first. I'm just going to do that. So let's have a look at this one first. So 7 minus x equals x plus 5. If I start to solve that, I get 7 equals 2x plus 5, which gives me 2x is equal to 2, which gives me x is equal to 1. The other one, x minus 7 equals x plus 5, well, the x is actually going to cancel each other out, leaving you with minus 7 plus 5, so that cannot be a solution, because minus 7 is not equal to 5. So it's not true, you can't solve it. So I don't need to carry on any further, so let's move on to my other solution on the right hand side. X plus 13 equals modulus x plus 5. So again, take the positive and negative variants. So either x plus 13 is equal to x plus 5, or the negative variant minus x minus 13 is equal to x plus 5. Well, again, if I look at x plus 13 equals x plus 5, my x's are going to cancel out, leaving you with 13 equals 5, not a solution. My other solution being minus x minus 13 equals x plus 5 can be solved. Minus 13 equals 2x plus 5, which gives you 2x is equal to minus 18, which gives you x equals minus 9. Last step is just to check to see if they both work, so let's put 1 in here. 1 plus 3 becomes 4, mod 4 is 4, plus 1 plus 5 is 6, mod 6 is 6, so 4 plus 6 is 10. That is true, so that does work. What about minus 9? Well, minus 9 inside my modulus is modulus minus 9 plus 3. Minus 9 plus 3 is minus 6, so modulus minus 6 is 6, so that is true. Sorry, minus 9 plus 3 is minus 6, so that is 6. And then the other one, modulus minus 9 plus 5, minus 9 plus 5 is minus 4. Modulus minus 4 is 4, so 6 plus 4 is 10, that is also true. Okay, have a go at this question yourself, and I'll give the solution to this in a second. So just pause the video, and then I'll start again with a solution. Okay, hopefully you had a good go at that and you were able to get the solution. If not, here is the solution now. So, because I've got the modulus brackets, I need to say that 4x minus 3 is equal to either positive 7 or 4x minus 3 is equal to negative 7. Quickly solve it. 4x equals 10, x equals 2.5. Does it work in my top thing? 4 lots of 2.5 minus 3 gives me 7. Is mod 7 equal to 7? Yes it is, so that must be true. 4x minus 3 gives me 4x is equal to negative 4. X is equal to negative 1. Try it again in your top. So 4 lots of minus 1 minus 3. Is that equal to 7? Well, 4 lots of minus 1 minus 3 gives me minus 7. Is mod minus 7 equal to 7? It is, so that must also be correct. 2 solutions. Hopefully you got that. Have a look at this question here, see if you can get it. So just pause the video and I'll start again in a second. Okay, hopefully you had a good go at that question. So this is a question where I've got moduluses on both sides. So I'm going to do the squaring variety of this because I just prefer it. So I'm going to do 2x plus 1 squared is equal to x squared. Okay, square both sides, gets rid of the moduluses. So let's expand the brackets. 4x squared plus 4x plus 1 is equal to x squared. Make it equal to 0. 3x squared plus 4x plus 1 is equal to 0. I can actually factorize this. So 3x plus 1, x plus 1. 1 times x is x, 1 times 3x is 3x, added together is 4x, 1 times 1 is 1, if you've forgotten how to do that. Make it equal to 0, so 3x plus 1 is equal to 0, so that means that x is equal to minus 1/3, or x is equal to minus 1. Do both of these solutions work? Well, let's try it in the top again. So 2 lots of minus 1/3 plus 1. Is that equal to modulus minus 1/3? Well, 2 lots of minus 1/3 is minus 2/3 plus 1 is mod 1/3. Is that equal to minus 1/3 modulus? Yes it is, so this must be true. Let's try minus 1. 2 lots of minus 1 plus 1. Is that equal to modulus of minus 1? Well, 2 lots of minus 1 plus 1 is minus 1, mod minus 1, and that is equal to mod minus 1, so this must also be true. So both solutions work here. Okay. Have a go at this question. So this is a simultaneous equation question. Let's see if you can work out what you'd need to do here and see if you can solve it. Again, pause the video and I'll give you a solution in a second. Okay, hopefully you had a good go at that question. It may have been a bit harder because obviously we haven't covered a question similar to this, but it takes some of the same principles as before. So, with a simultaneous equation question, you always have to replace one of the variables x or y. So, there's no point rearranging the equation with a modulus in because that's just going to be terrible. terrible to deal with. So you might as well just do the x plus 2y is equal to 8. So let's rearrange that. So x is equal to 8 minus 2y, and then you can replace the x here with 8 minus 2y, and then you can try and solve it from there. So modulus 8 minus 2y plus 2 plus y is equal to 6. We can simplify that bracket down, the modulus bracket, to 10 minus 2y plus y is equal to 6. I want to get rid of a modulus, so I need to get all of my other stuff to the right hand side. So modulus 10 minus 2y is equal to 6 minus y. Get rid of a modulus bracket, so take the positive and negative variant of the right hand side. So either 10 minus 2y is equal to the positive variant being 6 minus y, or 10 minus 2y is equal to the negative variant being y minus 6. Okay. Now I've got these two equations, I just need to solve them. So I'm going to solve them up. I'm going to solve them here. So this one gives me 10 is equal to 6 plus y, which gives me y is equal to 4. The other one gives me 10 is equal to 3y minus 6, which gives me 16 equals 3y, gives me y is equal to 5 and 1/3. Okay, now I've got two solutions for y. Let's find my solutions for x, because it's a simultaneous equation question. So again, I'm not going to worry about substituting it into the modulus. I'm going to substitute it into the one above because it'll be easier to deal with. So x plus 2y equals 8. So x plus 2 lots of y is equal to 8, and x plus 2 lots of y is equal to 8. Let's see if that works. So x plus 8 is equal to 8, which gives me x is equal to 0, or x plus 10 and 2/3 is equal to 8, which gives me x is equal to minus 2 and 2/3. Okay. Do both of these solutions work? Well, when y is 4 and x is 0, does this modulus here work? So when x is 0 and y is 4, is that 6? Well, modulus 2 plus 4 is 6, so that must be true. So one of my solutions is x equals 0, y equals 4. Okay, what about 5 and 1/3 and minus 2 and 2/3? So minus 2 and 2/3 plus 2 plus 5 and 1/3. Is that equal to 6? Well, minus 2 and 2/3 gives me minus 2/3 modulus plus 5 and 1/3. Is that equal to 6? Well, minus 2/3 becomes positive 2/3. 2/3 plus 5 and 1/3 is 6. So then this must also be true, and that is x is equal to minus 2 and 2/3, and y is equal to 5 and 1/3. So both solutions work. So that is the final example, a question we're going to go over. Hopefully you understood all that and you can have a go at some questions yourself now. Thank you for watching the video. I'll speak to you again soon.